division 2 and 3. I hope that you are in this meeting. Division 2 and 3.
Yes, sir.
Okay, in the last class, we have gone through the, what we can say, about the revision. Correct? So we have seen in the last session, that is what is meant by projection and types of projection. Is this correct? Is this correct? Aman Patak, is this correct?
Yes, sir.
Ashwini Kumar. Ashwini Kumar is there?
Hello, sir. This is Aman Pathak. Was I audible?
Yeah.
Okay, sir.
Ayush Patel is there?
Yes, sir.
Okay. Ruturaj. Ruturaj 80. Ruturaj is there? 8041. Ruturaj. Okay. So we have seen the main two types of the projection. One is the, who will tell me? The first one?
Orthographic.
Orthographic. And the second one?
Sir, isometric.
Isometric. So we've seen again this orthographic projection is classified as first angle and
Third angle.
Third angle projection.
third angle. Okay. This particular, we have seen the differences, right? Why we call this orthographic? Ortho stands for? Ortho stands for?
90 degree.
Yes, it is 90 degree or perpendicular. So when we say an observer is there, right? Then we have a, what we can say, the point or the object. So this is observer. This is object. Just a minute. Hello. So we have three things. One is observer, next one is object, and then we have the plane of projection. So we'll get the projection on this one. This is called as projection. Now, if I take any solid, if I take a regular solid, let us say any cube, a cube, This cube has total 6 faces. So there are total how many views are possible? 6 views are possible. Now to explain any object, to reveal any object, we require minimum 3 views, like front view and the name of the plane on which this we will get, that is called as VP or vertical plane. Then we'll get the top view on HP, and we'll get LHSV or RHSV on the profile plane. So these are called as principal planes of projection. Clear, everyone?
Yes, sir.
Now all this projection in case of orthographic projection is 2D projection. All these projections are called as 2D projection. While in case of isometric, this is the 3D projection. This is the 3D projection. If I just take an example of a cube, right? So this is the isometric projection. This is called as isometric projection. Okay. Now there are the two ways. Either we can, what we can say, the transfer this isometric into orthographic, or from orthographic to isometric, right? So we'll get the question which is based on isometric to orthographic or from orthographic to isometric. Okay. This particular projection is called as multi-view projection. This is called as multi-view projection. While in case of isometric, it is a single view projection. View means, what is a view? If I just looking at any object, we can see that object in the, what we can say, if I just looking at outside the window or towards any object, that is called as, and that is called a view. So here this is the single view, but here we will get 6 views. Out of these 6 views, we required minimum 3 views. So that's why this is called as multi-view projection. What is the advantage of this? Everything or each view, whatever we can say, if I just take the front view, top view, side view of any cube, all views will get the square, whether it is a front view or top view or side view or the top view. Each view is the square, right? So whatever the length, whatever the height, whatever the depth is actual one, is the true or actual. But in case of isometric, it is a apparent. It is not a true view. Whatever the length, whatever the height we can see here is not a true view. Okay. Now I will show you how we can convert this isometric into orthographic. Okay. Stop sharing. Now I'll show you something, what we can say, a application. I will share that also. Okay. So you can see here. Okay. So can you see this one?
Yes, sir.
Yeah. So this is the isometric projection of a object. So we will see, just a minute. Yeah. We'll go with a simple one. I will share the link of this particular application with you. Okay. Now you can see this is the isometric, what we can say, the projection of an object. What it looks like? What it looks like? ये कैसे दिखता है?
Stairs.
Hmm?
Stairs.
It looks like a stairs, right? Now what this arrow indicates at right hand side? What this arrow indicates at right hand side? You can see.
Observer.
Okay, it shows the direction of observer or view. Now you can see the different dimensions which is associated with this particular object. Just take a look at this. Read each and every dimensions. Okay, and tell me what is the maximum length of this object? इस object की maximum length कितनी है? What is the maximum length?
104.
104. What is the maximum height?
48.
And what is maximum depth?
72.
72. So we have a object whose maximum length is 104, maximum height is 48, 72 is the depth. We can see the three sides. So this is a 3D, and we can see the arrow. The arrow indicates the direction of a particular, what we can say, observer or viewer. Now, what should be the size if I want to draw a, what we can say, the view? Okay, so here we'll get a basically three rectangles. Just hold on, I'll come with it 2 minutes. If I want to draw the rectangle of this particular, sorry, if I want to draw the front view, the size of the rectangle is 104 into 48. If I want to draw the top view size is 104 into 72, and the side view size is of rectangle 72 by 48. Am I right? Is this clear?
Yes, sir.
Okay. फिर से मैं आपको बताता हूँ. Just a minute. That means if I want to draw the front view, or if I just draw the front view, the size of this is 104. Then the height of this one is rectangle is 48. Now the length in front and top is common. So it is 104. And the depth was 72. So you can see the length in front, and the top is same. So here we have to draw a 45-degree line, and we have to project on this 45-degree line. Then we have to project in the upward direction, right? And we have to take it in the vertical directions. And then we have to take horizontal, whatever the lines. So the intersection of this will get, this is called as LHSV. This is a front view, this is a top view, and this is LHSV. Right? Clear, everyone?
Yes, sir.
Yes, sir.
Please repeat.
Now, if I want to see the front, top, side of this particular previous problem, okay, just share it. So we have to draw the front view. Okay, so if I just draw the front view, it looked like this. You can see you are looking from the front. So you can see there are the three surfaces. Okay, and as I explained in the last lecture, if you just view, if that particular surface is perpendicular to eye side, it appears as a plane. Now on the top, on the side, both the side, on the base, there are the surfaces, but as they are parallel to eye side, it appears as a line. So if I just see the front, it look like this. If you see the top view, it look like this. And if I just see the side view, this is a which side view, LHSV or RHSV?
LHS.
LHSV. Okay. And if I want to draw all these three view by using a first angle projection, it look like this. Front view 104. Then the height is 48. The length is common in between front and top, while the depth is common in top and the side. Now, if I want to draw the same drawing in third angle position, third angle, what would be the change? Anyone? If I want to draw the same thing using third angle, what would be the change? अगर मुझे यही ड्राइंग थर्ड एंगल में ड्रॉ करना है तो क्या चेंज होगा?
Object in the third quadrant, below HP and behind VP.
So this is the projection in third angle. You will find the top view is above XY line, the front view is below XY line, left hand side view is at left, and you can see on the there you can see the symbol. As I explained in the last lecture, the symbol is nothing but it is projection of a frustum of cone. It shows the front view and LHSV. Got it, everyone?
Yes, sir.
Clear, everyone?
Yes, sir.
सबको समझ में आ गया?
Yes, sir.
For you, just a minute. I will show you how this we can do in a animation, so that just a minute. That object is not there. Okay, we'll see this one. Just look at the object. Now you can see that this is a different kind of the object. The arrow indicates the direction of viewer. Now, if I want to see the front view, the front view is look like this. If I want to see the top view, The top view is look like this. Now here you can see the two dotted lines. What this dotted line indicates? Anyone? What this dotted line indicates? You can see the two dotted lines are here. What these two dotted lines indicates? ये दो dotted line क्या indicate करती है?
सर वो नीचे वाला जो पैग है उसे.
Yeah. So whenever any edge or the what we can say edge which is not visible to observer, we have to show it by a dotted line. So we are talking as a dotted line, but generally we are drawing as a dashed line. So in engineering drawing, we required lines which are frequently used. The first one is the continuous thick line, which is you can see here. Well, you can see the another line that is called as the dotted line. The dotted line shows what we can say the object, the edge which is not visible to the observer. Now you can see the side view also. You can see again the two dotted lines. These dotted lines indicates the hidden edges which is not visible to the observer. Clear everyone?
Yes, sir.
Yes, sir.
I will see another object. Just try to imagine the front view. Try to imagine the top view and the side view. Now I'll show you the front view of this. So you can see there are the two vertical dotted lines and one horizontal dotted line, which indicates the edge, which is not visible to the observer. We can see the top view. This is the top view. You can see the main rectangle. Within that, you can see the three rectangles. Again, if you just see the side view, again in the side view, you can see the two vertical edges indicating the.
Sir.
Yes.
Sir, what is this horizontal dotted line?
Horizontal dotted line. Okay. Now you can see we have at the left hand side, we have this protrusion or one rectangle, and behind that one edge is there, right?
Yes, sir.
And if I just see from the side, this edge is not visible to the observer. That's why it is to be drawn a dotted line.
Okay, sir.
So while in case of the right hand side, this edge is visible to the observer, change of plane. So that's why we have drawn it by a continuous thick line. Okay.
Okay, sir.
We'll see the third object. This is the third object. So right now in this particular applications, the dimensions is not given. Just imagine the object. If I want to draw the front view, it look like this. You can see there are the two dotted lines, horizontal dotted lines, which indicates the lines which is not, or the edges which is not visible to the observer. If I want to draw the top view, the top view is like this. Again, we can see the two horizontal dotted lines, which indicates the edges which is not visible to the observer. And just try to imagine the side view. Just try to imagine the side view. Now I'll show you the side view. This is the side. Now this side view is as per the LHSP or RHSP. In the left hand corner, upper corner, you can see the 3D of that particular object. Now whatever we have drawn here is LHSP or RHSP.
Yes, sir. RHS.
RHSP, correct. It is a RHSP. This is the next component. From the right is the front. Just imagine the front view. I will show you the front view. Now on the top, you can see one horizontal line that indicates that surface, horizontal surface is there. It acts as an edge or hidden edge. And if I look from the front, it appears as a dotted line. If I want to see the top, you can see the top view. In the top view, all the lines are visible. No dotted line is there. Now, we can see the side view. Now tell me whether this is the left-hand side view or right-hand side.
Left-hand side. Left-hand side.
Yeah, this is the left-hand side. We will go for the next component. Just imagine this particular object. We are looking from this front length. Now you can see if I want to draw the front view, it appears horizontal, the base, and in the middle, one vertical, what we can say, edge is there. So the front view is look like this. Now you can see there are total 6 dotted lines. What this dotted line indicates? What this dotted line indicates? Can anyone tell me what this dotted line indicates?
Sir, holes and the axis of holes.
Yeah, so you can see there are total 3 holes are there. And if I just see these holes, the vertical holes has 2 generators, extreme generators are there. And we have to show it by a dotted line. Now here on the top, we have a horizontal circle hole, and that's why we have to draw it 2 horizontal dotted lines. So if I just show you the front view, the front view is look like this. In between that, you have to show the third line, that outline dotted line we know. Now we can see the third line, that is the axis line. What is the use of this axis line? Anyone? What is the use of this axis line? Axis line कब use करते हैं? Yes?
To find the radius of the circle or something.
No. Axis line का use कब करते हैं? कब दिखाते हैं axis line? So whenever any object is symmetrical about axis, we have to show this axis line. Now this axis line indicates whatever this particular entity is there, that hole is there, which is symmetrical about axis. So we have to show it by axis line. And what is the nature of axis line? One long dash and one short dash. Everyone clear?
Yes, sir.
Okay, so we have seen first line is continuous line, next one is dotted line, and third one is the axis line. Axis line indicates the object or that entity is symmetrical about the axis. Now we see the top view. In the top view, you can see this. There are the two holes on the base, which is visible to the observer. But you can see on this middle part, there is a horizontal hole, which is not visible. That edges or the generators are not visible to the observer. So it should be shown with the dotted lines. And for the symmetry, to show the symmetry, the axis line is used. While you can see the two dotted lines are there, that you can see that indicates the edges in the bases. The base major, what we can say, the hidden edges are there, which is not visible from the top view. So it should be shown with the help of dotted line. Clear, everyone?
Yes, sir.
Now we'll see the side view of this. Just imagine the side view. Now in the side view, you can see the top circle is visible from the side, but there are the two holes which is on the base. They are aligning with each other, so we can see only two dotted lines, while the horizontal line indicates the edge in the base. You can see in the edge in the base. Okay, so this is the correct method to show the axis line. Axis line should be somewhat extended beyond this particular object, slight extended beyond this particular object. Okay, now we'll see this another, what we can say, this particular application. Just give me 2 minutes. Yeah. Now we have seen this particular, this particular thing. Now you can see this, the dimensions. The total length is 75. The height of this particular object is 50 and depth is 63. So in the front, we can see the length 75, height 38 plus 12, that is 50. As well as you can see there is a middle half cube cutted. We can see there. Top view. This is the top view. And the side view. Now we have seen this view separately, but if I just show you all three views in one, what we can say, as per the first angle projection method. So you can see the front view, top view, and the side view. So this is the correct method of showing the orthographic projection of an object. In some cases, you can show the name of the views, like it is written front view, top view, side view, as well as you can see the dimensions, how the dimensioning is given. Do you know what are the types of dimensioning? As I think we have discussed in the last lecture, do you know what are the methods of dimensioning? Okay, before that, if I want to draw the same orthographic projection in third angle, what will be the changes? Anyone? क्या changes होंगे third angle में? Am I audible?
The top view will be above XY and the front view and left hand side view would be below XY.
Below XY. But here the left hand side view is at right of the front view, but in third angle, left hand side view is at left side. So we can see this is the left hand. This is the projection of methods in the third angle projection.
Yes, sir.
Right? Now, do you know how to draw it? Okay, मैंने तो अभी आपको front view, top view, side view दिखाया है, इसलिए आपको आसान लग रहा है. But do you know how to draw it? आपको पता है ये draw कैसे किया जाता है? और आप ड्रॉ कर सकते हो इसको देख के. अभी समझ में आ गया आपको कैसे ड्रॉ करना है? 103 लीना, डू यू अंडरस्टूड? Eight 8103.
Yes, sir.
104 8104. Mahesh, suppose if I give this particular isometric, can you able to draw the three views? अगर हमने फ्रंट व्यू, टॉप व्यू, साइड व्यू अगर साथ में देखा है तो अभी देख के आंसर को देख के तो समझ में आ रहा है, but can we able to draw it if I give something new? देखो, when we want to convert the isometric projection into orthographic, that is किसी 3D को देख के 2D को बनाना है, या from 2D we have to create a 3D, we have to maintain the relation or just think of the relation in between the 3D and what we can say the 2D. Okay. So in this particular subject, your offline practicals has been commencing or it is going to be started from Monday. I hope that चालू हो गई.
Yes, sir.
तो on which topic you are just drawing? अभी कौन से टॉपिक पे आप बना रहे हो? Orthographic isometric is there? I think today there was a class of few groups or one group. आज आपका क्लास था ड्राइंग का डिवीजन 1 2 3 में से किसी का?
Yes, sir.
तो कौन सा टॉपिक सर ने पढ़ाया?
Isometric.
Okay, that means from orthographic to isometric, right?
Yes, sir. Both.
Okay, both. ठीक है. By looking at this particular examples, can you imagine iso to ortho and ortho to iso? Or do I need to explain more? Ruturaj.
Yes, sir.
Do I need to explain more or you able to imagine the answers?
Sir, by drawing practically we will be able to do, sir.
Now let us say if I just give another problem here, or I'll just use a simple problem. Just a minute. Yes. Now just looking at this particular object, can you draw the front top side?
Yes, sir.
Yes. Okay, that means you understood how to convert the orthographic into, sorry, isometric into orthographic, correct?
Yes, sir.
So if I just show you the three view directly, is this the solution for this? Ruturaj?
Yes, sir.
Okay. Right. So it is right now, yes. If any doubt, please ask me. Yeah.
Sir, will there be a dotted line because of that big hole on top view?
It is there, no? Dotted line is drawn here. You can see in the top view. You are talking about the top view?
Front view, sir, front view.
Yeah. So in the front view, you can see the half circle is visible of diameter that is R30, radius 30, and in between there is a small hole that is 530. Now you can see the two dotted lines are there. Can you see that two dotted lines?
Sir, will there be a center dotted line?
That is there, no? You can see here. And maybe you can see something. Okay, I'll just try to enlarge. Okay, enlarge nahi ho raha hai. Okay, so if I want to show you, आपको दिख रही है क्या वो एक्सिस लाइन, डॉटेड लाइन के एकदम नजदीक में? Can you able to see it?
Yes, sir. Yes, sir.
Yeah. So you can see it is there. If I will show you. Yes. Just a minute. Oh, no. Yes. Now here you can see. Can you see these two dotted lines?
Yes, sir.
These are the two dotted lines. One is here, another one is here. And beside this, you can see the two axis lines are there. Okay. So this indicates what we can say. The symmetry. Yeah. This hole. On the top, you can see here is the dotted line. And this line indicates the axis line, which is from here. Here also you can see this, if I just draw it, if I just connect this, and you can see the axis line, if I just connect, these are the axis lines. And in the side view, just a minute. Yes. So in the side view, you can see these two dotted lines, vertical dotted lines, indicates this. If I just draw the 45-degree line, so this indicates this. While we have one dotted line here, horizontal line here, we can extend this axis line. And if I just look from this direction, we can see this edge, this edge. So this is to be, now as this is the left hand side, we can see that edges, so it should be a dark line. And what about this dotted line? So this dotted line, if I just extend this circle, so you can see this is the dotted line. Clear, everyone?
Yes, sir. Yes, sir. I got it.
Yeah. So likewise, we have to think how we can draw. No doubt, whenever we meet in the actual class, I will show you on the board how to draw. I think, sir, he is already explaining. You will get the process, how we can convert ISO to ortho and ortho to ISO. But still, the available time is very less. So that's why what we can say. Again, I'll explain it, refresh it again during the class. But to maintain the continuity in subject 1 and subject 2, I think this is important. That is, you must know orthographic and isometric correctly. Clear, everyone?
Yes, sir.
Okay. Now we have seen orthographic, that how we can convert the isometric, orthographic from isometric. That तीन व्यू, एक व्यू से या 3D से तीन व्यू बनाना है. ये थोड़ा आसान लग रहा है. I will share that particular application on your WhatsApp group. Please install it, and this will help you to solve some problems for the imagination also, right? Because you are all are what we can say from the generation of techni-savvy world. So if you just use these particular applications, you can easily understand how we can convert ISO to ortho and from ortho to ISO. I have not explained how we can convert from 3D to 2D to 3D. Now, for this particular subject, I am the in charge of all divisions, but simultaneously we have other faculties also, which will help us in practical. So they will be also from next week onwards. They will also give some input in other topic like sectional orthographic projection, isometric, then what is assembly, how we can do the assembly. And meanwhile, also I will, what we can say, also teach you. Okay, so for the first 2 weeks, uh, that means last week and this week, I have uh, revised how we can draw the isometric into orthographic projection. So from the next class onwards, some like Anantapu sir or Junarkar sir will teach you the remaining topic or just briefing. Online teaching में हम ज़्यादा आपको पढ़ा नहीं सकते, हम खाली आपको brief करा सकते हैं. But whenever you finish your semester 1 practicals and whenever we get the chance of semester 2 practicals on the board, I will show you again these things in detail. We'll discuss face to face. And if any query, any doubt, we'll solve here. But I think this will help you in this ongoing lectures also, right?
Yes, sir.
Okay. Is there any query? Others? Okay. Now I'll show you something, what we can say, the more problems from this particular application. We'll go for the next problem. Just a minute. Yeah. So we'll take the problem which we have seen in the last thing. This problem we have seen in the last, what we can say, the previous, before this one. So this is the particular dimensions of this particular object. And if I want to see the front view is look like this. Top view. And the side view, in this case, the left-hand side view and the right-hand side view is same. So if I just draw in first angle projection, it look like this. Now this side view is LHSV or RHSV? This side view is LHSV or RHSV? Mahesh 340, 8104.
Yes, sir.
This is a left hand side view or right hand side view? जो side view हमको दिख रहा है यहाँ पे.
Right hand side.
Right hand side view. Why it is right hand side view? Because it is placed at left and in first angle, whatever the side view which is at left, it is called as right hand side. If I just show you the same drawing in third angle projection, same thing, the top view is above XY line, front view is below XY line, and the right hand side view is at right. We'll see some next problem. The arrow indicates the direction of observer. If you imagine the front view size is 100 by 100, the top view is 100 into 108, and the side view is 100 into 108. So if I just show you the front, this is the front view, the top view. and the side view. And if I just show you all three views together, it looks like this. So there are some tricky problems are also where the imagination is a little bit difficult. Okay, whether they are very small, but it is very tricky kind of thing is there. Okay, so in days to come, I will share that problem also on WhatsApp group, or I'll put up all this information as and when required on the what we can say Moodle. Are we able to access the Moodle?
Yes, sir.
Okay, so I'll share this thing on the Moodle, the questions and etc. And I'll share this link of this particular app on your WhatsApp group. Okay. Any doubt? Anyone?
No, sir.
Nikhil Singh, 1, 2, 3. Are you there?
Yes, sir.
Okay. Nishant Shinoy, 174 is there. Nishant Shinoy. Sagar Sawant. Sagar Sawant. Don't worry, I'll remember this name. And I'll tomorrow in the class. Your class is there. Which division you have class tomorrow? Drawing practical morning में किसका practical है? कौन से division का है? 3 का कि 2 का कि 1 का है? किसका है?
3 का तो नहीं है सर.
1 का? Division 1 का है?
सेकंड में नहीं है सर.
सेकंड डिवीजन का नहीं है. डिवीजन 1 का है क्या कल? तो शायद मुझे लग रहा है डिवीजन 1 का होगा, राइट? Okay, no issues, right? So I hope that you can little bit imagine that what is the problem, that is what is isometric and how we can convert that isometric into orthographic, at least looking at the solutions. Drawing method we can see in detail later on. Okay, how we can see this particular the process, how we can convert. Sir maybe already explaining you, but again we'll go in some detail of that. And now in this, the objective of this particular subject is to draw the orthographic and isometric of actual object. That means right now we have seen this a regular object, a few machine components, and in the next step we'll see some actual components in assembly position. So if there is, let us say, one pen, the pen is in if I just see the pen is made up of different components together, or different components are connected together. That is called as assembly. So we have to draw the drawing of the assembly in close position. अगर पेन का मुझे फ्रंट व्यू ड्रॉ करना है, टॉप व्यू ड्रॉ करना है, साइड व्यू ड्रॉ करना है, तो किस तरह से उसको ड्रॉ करना है, etc. Now there is another topic that is called as a sectional orthographic projection is also there. So in days to come, Tapu sir or the Narkar sir will explain you. Okay, they will brief you how to draw the sectional orthographic projection and what is the requirement of sectional orthographic projection, how we can convert the orthographic projection into isometric, or what about the different assemblies. Okay, so I think you got the little bit about this, how we can imagine this orthographic projection from an isometric projection. Right, everyone?
Yes, sir.
Okay.
Yes, sir.
So with this, I'm concluding our today's Yes. So with this, I'm concluding our today's sessions. And if you have any query, any doubt, maybe from tomorrow I'll be there during your drawing class also. So if any doubt, any query, you may ask me also. Okay. Yeah, I'll give the app link. Don't worry. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Jain sir.
Jain, Jain.
Thank you, sir.
Jain sir.
Jain, thank you.